All right, so the graph. Right here, we have the initial point, and we know that it's x0, y0. At this initial point, the gradient of the curve is fx0, y0. We know this through dy dx. We move a small step size along the x-axis, such that x1 equals to x0 plus h. Using the gradient at x0, y0 from the original curve, we can draw a tangent line and take its value at x1 over here. This will give us an approximate value of y1. We can repeat this process for y2, y3, and so on. Derivation of the curve of the Euler's method. Let the curve be y equals to yx, since we know that dy dx equals to fxy. For example, if we take a point x and yn on the curve, the gradient of the curve, will be fx and yn. If we move a small step size h on x-axis, xn plus 1 will become xn plus h. So y minus yn equals gradient multiplied by x minus xn. We replace x as xn plus h, and we will get yn plus 1 minus yn equals to the step size multiplied by the gradient. We move the yn from the left side to the right side, and we can get the Euler's formula. All right, so for the Excel sheet, initial x is 0, initial y is 1. So the gradient is actually x squared plus 2 over y. And we can get this through a2 squared plus 2 over b2. For your b is actually using your Euler's method, because your b is actually y new, so you need yo plus step size multiplied by the gradient, which is b2 plus 0.5, which is the step size, multiplied by c2, which is your gradient. We can drag this along and we can find for all the coming solutions. Now for the error between the general solution and your Euler's method, right? So first we have to solve using general solution. So dy dx equals to x squared plus 2 over y, which is given. So we want to move the dy to left side, dx to right side. So y dy equals to x squared plus 2 dx. Integrate both sides such that you get y squared over 2, x cubed over 3 plus equals to x cubed over 3 plus 2x plus c. Here we can solve around y, and we can solve for c, where c will become 1. So we replace c equals to 1 back into the original formula, such that y squared will become 2x cubed over 3 plus 4x plus 1. Now this is actually y squared. We want to find y. So we have to square root everything to find y when x equals to 1. After that, we can solve for y, which is actually 2.5625. Note that this is actually using, 2.3805. This is using general's solution. If we want to use Euler's method, as you can see from the Excel sheet, it's actually 2.5625. So the error between these two, we can find out by minusing both of them. So 2.5625 minus 2.3805, you actually get an error of 0.1820. Take that over 2.3805, which is from your general solution once again, multiply by 100%, you get 7.65%. Thus, the Euler's method is actually 0.1820 with a 7.65% error. This means that the Euler's method actually overestimated the actual value. Thank you.